Okay. First, we should have a review of the definition of the derivative of a function, which have been introduced by Ms. Jo. Review. When this is the definition. This is the definition of the derivative of a function, right? And we have the following formulas. The first one, the derivative of a constant c is equal to
0.
0. Yes. And the second one, the derivative of xn here.
N
x minus 1.
to the power n minus 1.
Yes. Of course, you remember this one, right?
Yes, Loshi.
Yes, coach.
Okay. Then the third one, the derivative of sin x.
Inverse. Minus cos x.
Cosine x.
Yeah, cosine x here.
Minus
What?
minus Laushi.
No,
No.
Look at this. The derivative of sin x is equal to cosine x.
Yes,
But
Yeah.
last
Yeah, you
last
should.
lecture, Laushi is telling that derivative of sin x is equal to minus cosine x.
no, bro.
No, that's
You can look at the next one.
minus sin.
Here, the cosine, the derivative of the cosine
Oh,
x.
sorry.
Here,
Minus
Sorry,
Sin
Laushi,
x.
little misunderstanding.
yeah, minus sin x. Here is the minus, right? Okay. And the fifth one. The derivative
This one now.
of ex
Either x.
Is equal to
AX.
equal to-
Ex.
Yes.
itself, right?
Yeah.
Inverse.
Are how this-
One.
this now-
The derivative of log x,
1 by x.
X.
1 by x here, right? And the derivative of tangent x. Do you remember this one?
6 square x.
Yeah, second square x here. And this one, the derivative of second x here.
minus 10 square x.
Minus 10 square.
Plus 10 square x. Sec x 10 x.
Yeah, second x and times tangent x here. Next one, the derivative of arctangent x. Can you check your notes?
Lauchi, she didn't.
Last class, we just had 8.
Oh, you just have 8. Okay, we just stop here. Okay.
Laushi, finish that formula. Laushi, finish that number 9.
Finish it, Laushi, we need that.
Okay, today we will not use this one. So you will
Just for
well,
note, Laushi. Just for
not
take a
this
note.
time, okay? Okay, and we also have the prime type, right? With this one, you can write this as a C prime, right?
Prime.
Yes.
Yes.
And then you can
X
rewritten
power
this
n
one, the
X to the
prime
power n prime.
prime type, right? And this will help us simplify the representation of this one. Cosine X prime, and this one. This is the
ln prime.
ln X prime, right? And these are the formulas which you have learned before, right?
Yeah.
And this time we will continue learn the derivative of the function. Okay, wait me a moment. Here. And we know that the derivative of a function reflects the rate of the change of a function, right? Yeah, do you remember?
Yes, Laushi.
Okay. A derivative of a function reflects the rate of change of a function. And let's go on see the geometrical meaning of the derivative today. For example, let's see. When fx is a constant b, and the derivative of constant is equal to 0, right?
Yes, Laushi.
Yeah.
And this one, we can see the derivative of a constant function is 0 here. Is a 0 when c is constant here. And this means that the rate of change of this function is 0. That means the function has not changed, right?
Yeah.
And from the graph, we can see here.
Line.
Yeah,
yes.
yeah.
Horizontal of x.
Okay, when it is this fx is a constant c, this constant function is a horizontal line, right?
Yes,
Yeah.
Laushi.
That means the function has not changed. Okay, and you can see from the graph, at every point, the values are the same. That means the rate of changes of this function is 0. That's what the derivative means here. And this time, we will learn the geometric meaning of the derivative, which is written as geometric meaning of the derivative, which you can see. In this graph. Here is a function fx, right? And this is the point x0. And after an increment, there is a point x0 plus delta x here.
Yeah.
And for each point, we have the value of the function.
y0 and y.
Yes, f of x0. And this one,
F of x1, x0 plus delta x.
yeah, x0 plus delta 0 here. This is the graph here. And from the you can see we can connect these 2 points. We can connect these 2 points to make a line. One. And you can see from these 2 points, we have line. And from definition, we have here the differential of fx.
Limit.
Yeah, limit here is not x approach to x0, it's delta x approach to 0 here. Limit fx0 plus delta x minus fx0. Here is delta x here. And we can see.
Laoshi,
Yeah.
can you repeat this step? Y f of x0 plus delta x and not f x.
It's the same. It's the same here. Sorry.
Laoshi, if
you replace this one, as f as x, and the delta x is x minus x0, right? And
Yes,
this
yes.
one is x.
that's what I was saying. That we
Yeah,
can
it's
replace that, right?
Yeah. It's the same. It's the same representation here. We just change the
Yeah, Laoshi.
denotion of them. Okay. And you can see when we connect the 2 points to make this line, and the quotient here means that the slope of this line.
Yeah.
Yeah, right? That means the slope of this line. This quotient means the slope of this line. Slope. And if we get the limit at delta x approaches 0, that means this point. That means this point moves to x0, right?
Laoshi.
And so we can get a tangent line of this function. We can get a tangent line of this function here.
Can you be clear, because I didn't understand
Here.
this part?
Yeah, the tangent line.
Laoshi,
Okay.
Laoshi,
Any question?
I didn't understand this part.
Where?
This all part. I didn't understand.
You can draw in the page. This line. Oh, this.
Yeah.
This equation, the definition of the derivative here is the equal one. Here, you just replace this x as x0 plus delta x. Then this one is delta x, right?
Mm-hmm. Right.
right? Here, we
Yeah.
replace x as x0 plus delta x here. And x minus x0 is equal to delta x. And this one is equivalent to delta x approaches to 0 here. Then they are the same representation here. Okay?
Okay, last.
Okay.
Let me have that.
Oh, sorry. Then we get a tangent line of the function here. Sorry, the line and make it not very successfully here. Then we can get when they know this one, the quotient here means the slope of this line. And if we get this limit at delta x approaches 0, that means this point approaches this point x0 plus delta x approaches to x0. So we get this tangent line here. And we call this one as the tangent slope. At the points
x0.
at the point, yeah, x0, f of x0 here, right? At this point, yeah. Yeah, then we can conclude that the geometrical meaning of the derivative here is the tangent slope at the point, at this point. This is the meaning of the geometrical here. Any questions?
No,
Can you
Lord.
repeat it again?
No.
Okay. And here we have an example to help you understand this way. This help you understand this geometric meaning. First one, if I give you a function here, fx equals to 1 by x here. And I want to know the tangent slope at a point to find the tangent slope at the point to 1 by 2. So how can we get this tangent slope?
It's fx minus fx0 by x minus x0. And
Okay.
x0 here it's equal to.
Okay, let's go on. And here, this example is about the understanding of the geometric meaning of the derivative. So here we just get the first, we get the differential of this function, right? df by dx is equal to d
by the x of
X,
1 by
so we can also write this as x minus 1.
minus
Right?
1.
Yeah,
Yeah.
yeah.
Yes,
We can get use of our formulas which has been introduced here by dx here. And this one is equal to what?
minus 1 by x power 2.
Minus 1 by
X
X,
power
Industry.
minus 2.
minus 2, right?
Minus-
And
Yeah.
often we write this one as minus
Minus 1 by x power 2.
this form, right?
Yeah.
And we know that when at the point, this point, 2, 1 by 2, we know that here x0 is 2, right? In this point, at this point, x0 is 2. And the corresponding df by dx when x is 0 equals to,
We substitute by 2 in
Yeah.
1 minus 1 by x squared.
yeah, replace x by 2 here, right? Is equal to,
Minus 1 by 4.
yeah, it's equal to this one is 1 by 4 here. And this means that the tangent slope at this point, 2, 1 by 2 is minus 1 by 4, right?
But Laushi, how we can graph this this tangent?
Oh, okay. So this one is the geometric meaning of the derivative. This one, the meaning, the geometric meaning of the derivative, it means that the tangent slope at this point. The tangent slope at this point. And also, you can see here, this geometric meaning, this differential means the tangent slope at this point. It's the geometric meaning of the derivative here. So when we get this derivative, we can see the tangent slope at the point 2, 1 by 2 is minus 1 by 4, right?
Yeah.
Any questions?
Laushi, can you graph this this tangent, please?
The tangent slope?
Yeah, at the point 2, 1 by 2.
Here, this point is when x is 2, fx
Yeah.
is 1 by
1 by
2.
2. Yeah.
Yeah, you can see in this one, this point, when x is 2, right? Its corresponding value of function is f2. Here, f2 is 1 by 2 here. When we can locate this point, right?
Lauchi, if we change the point,
You can
will
get
get
the
another tangent
different
slope.
tangent slope when you
Okay, Lauchi.
yeah, when you add the different points here. So you when you choose the other points, you have the other corresponding difference here. Okay.
Laushi, can I use the annotation, please? I want to explain something.
Okay.
This it's 2 here
Yeah.
and 1/2 here. But and suppose the function is like this. How we can the tangent it's like this.
क्या बोला?
I don't understand now she.
Luzina.
Are you clear about this one? The geometric meaning here?
Yeah, Laushi.
Yeah, it's the same. When the graph of fx is different, you can also get this tangent slope here when there have different
Most
graph.
of the time, we don't need graph in this math.
Yeah. Here you don't need the graph here.
We just need to clear the equations.
Yeah.
Thanks.
And also we can get the equation for this tangent line. The equation for, sorry. Also, we can get the equation for this tangent line. And in this example, we can find the equation for the tangent line. At this point, at 2, 1/2, with the slope
-1/4.
-1/4. And here we will use the point. This one, we will use the point slope equation. Have you learned this one? Let me introduce. Maybe you have some.
We read the language that's
Yeah. If
unknown. If
we know a line passes a point,
Okay.
yeah, you know that, right? X0, Y0 with
Slope.
a slope K here. Then we can represent this line, this equation of the line as y minus y0 equals to k x minus x0 here.
Yeah.
Right? Yeah, this is the point slope equation here. Then we can use this formula to get the equation for tangent line in this example. Here we have the slope is this one, right? Is -1/4. And we have this point 2, 1/2, right? Then we can write out the equation for this tangent line is 1 minus y0. Y0 here is 1/2, right? And the slope is -1/4. And
X minus
times x minus x0. Here x0 is 2. Yes. And we get the final equation of the tangent line.
Y equals
to
-1/4x
and
plus
-1/2.
by 2
plus 1 here. You
Yeah.
should
1/2 plus 1/2.
right?
Plus.
Plus 1/2 and plus 1/2. Then it's 1 here.
Yes.
Right? Then this is the equation for tangent line we want to know. And you can see in this example, this is the geometric meaning of the derivative here, the tangent slope, right? And that means the tangent slope at the point. And then we finished this example. And can you do an exercise to practice this one?
Yes, Lakshmi.
Okay.
Now,
Here. Here, we know the function f(x) equals to x3 here to find the equation for the tangent line at the point 1, 1. Okay, you can do here. Write it in your paper, and after you finish it, you can send it in our WeChat group. I'll check it. Okay. You can refer to the example we introduced here. If you finished this practice, send the picture in our WeChat group, okay?
Okay, Lakshmi.
Actually, can you check?
Yeah, you are right, but you should written as this form. Okay,
Yeah,
follow the steps.
yeah.
Can you check mine? Akshay?
Yes, I'm checking now. You do the round calculation at the last step. Please check it, okay? 1 minus 1 equals 2.
Oh, sorry, Lakshi.
Yeah. Check it, this one.
It's maybe 3x minus 2. The answer is 3x minus 2. Am I right, Lakshi? Yeah, Lakshi, I got it.
Okay.
Yeah.
Any others? Lin Yiran, you are right. Your answers are right here.
Lakshi, can you check this time?
Yeah. Y equals to 3x minus 2. Yes.
Every time I did that mistake. Every time.
The
My equation-
calculation.
Yeah, Lakshi.
So you should be more careful, right?
Yes, Lakshi, and I am worried about that on examination.
Yes.
Lashi, can you check mine, please, Lashi?
Okay. Yeah, all received are correct here.
You got the bullseye.
Yeah. So let's go on. I think you mastered this point, right?
Yes, Lakshi.
The
We
geometric,
need to practice more.
okay. The geometric meaning of the differential here.
That was easy, but when it come more complicated numbers, then we just messed up.
Okay. Yeah.
Those bigger equations will.
But Laushi, I have a question. Laushi,
Just say, okay.
Someone did
What's your question?
the slope, it's fx minus fx0 by x minus x0, not limit of x approach to x0.
You mean here?
Yeah.
You mean, oh, sorry. You mean here?
Where? Yeah.
You mean here, right? Okay.
Yeah. The slope, it's just fx plus delta x minus fx0 by delta x, not limit of when delta x approach to x0.
Yeah, you can see when in our initial definition, here is the fx minus fx0, right?
Yeah.
And here is the x moves to x0, right? here, limit here is x approaches to x0, right?
Yeah.
Yeah, and when delta 0 approaches 0, here, when this one approaches to 0, we can say this point moves to x0. So they are the same representation here. Can you follow me here? So
Yeah.
this is x when the difference of them is delta. Sorry, it's not 1. The difference of x and x0 is delta x here. And when this one approaches 0, x approaches to x0. Am I clear this time?
Yeah.
Yes, sure.
Okay.
Hamilton.
Yeah, all received the pictures are correct here. I think you master this point. Let's see. Here, first, to solve this question, we have to know the tangent slope of the tangent line. And, oh, sorry, here is a point, t is left by me. And first, we should calculate the derivative of this function, right?
Yeah.
Yes, professor.
So first, we get the
3x
derivative of the function is df by dx is equal to f is x3, right? By dx. And it is equal to
3x squared.
is equal to 3
X squared.
x
2 minus 1.
minus 1 is equal to 3x squared here. So this is the first step. We calculate the derivative of this function, and we know the tangent slope.
F prime of 1.
dx by dx at this point at x is equal to 1, right? At this point is equal to
1.
3 times replace x by x is 1, right? And it's 1 square equal to 3 here. Thus, we know the tangent slope is 3 here, right?
Yeah.
Yeah, we get the tangent slope, then we want to find the equation for the tangent line. And we have this slope, we have this point. Then by the point slope equation.
Plus by 1, 1.
Yeah. We can get the equation. We can get to the equation. Y minus y0. Here, y0 is 1. And
the slope is 3.
Okay, slope is 3 times x minus x0. Here, x0 is 1, right? Minus 1. Then simplify this equation. We get the final.
Lakshya, could you please write down that formula? Then we can note that.
Which formula?
y minus y0.
y1.
Here. You can see here. It's here.
Oh, sorry, Lash.
It doesn't matter. Then this is the y0, x0 here, this point, right?
Yes.
Yeah, then we get the final answer.
3x minus 2.
Y is equal to 3x minus 2. So don't do the wrong choice here. Okay. Be careful here when it's easy. So we get the equation for tangent line. In this example, is y equals to 3x minus 2. And this is the result we want to find. So we finished this example. Any questions here?
No question.
Okay, let's go
Oh,
on.
shit.
No.
Okay, these two examples are about the geometric meaning of the derivative. So after that, we will learn some differential rules here. Sorry. Differential rule here. These rules are very important for us to calculate. So yeah, I hope you can remember these rules here. The first one is called the sum rule. The differential of sum of f and g. Yeah, f, g are two functions here. The differential of f plus g here equals to df by dx
Plus
plus df
dg.
by
dg.
oh, so sorry. Sorry. Is plus
dg.
dg by dx.
Yes.
Right? This is called the sum rule here. And also we have the difference rule.
F and G to difference.
Yeah,
Right.
the differential of f minus g by dx equals to
df plus dx minus dg by
yeah. Minus df. Also, sorry, I make the wrong again. dg by dx. This is the first rules here. We call the sum rule and the difference rule here. And the second one is called the product rule. And you can see it's related to the product of the functions.
Yeah.
The differential of the product of f and g here by dx equals to, here f, g are two functions. You should be concentrate on this one. F, g are all functions here. Then it's equal to f times dg by dx plus g times
df
df by dx here. And also, we can write this one as a product type. It's equivalent to the product is 1 equals to
F prime G.
F prime G plus G. Sorry. Here. This is the product rule. You can see when F is itself, we want to times the differential of G here, right? This is called the product rule here. And there is a special case when G is a constant. This is the special case of the product rule. When G is a constant C, then it's CF here. Here C is a constant.
Now it's C.
Yeah.
By the X.
Yeah, C times F. Here, G is a constant C. Then in this case, the differential of CS is equal to C times dF by dx and F times dC by dx. And you should know this one. This
DC
value
is zero.
is 0, right?
Zero.
Is equal to
Right.
0. Then this factor is 0, right? It's equal to C
Dot
X.
dx.
By the X.
dF by dx here. So when there are one function with a constant, it's just one factor here, right? And when there are two functions, there are two factors here. And when there is a constant, one of them is equal to 0. And this one is a special case. It's a special case of the product rule. And you should remember this one. You should remember these rules. And next, after some difference product, we also have the quotient rule. Here, I will give you some examples to understand the product rule here. Let's see. Sorry, this one is
By
maybe my pen is low battery. Okay, when here fx is
F by G.
yeah d, here is 5x here, then we can make use of this formula, right?
Okay.
Yeah.
Yeah, here C is 5 and F is X here. Then it's just equal to this one. C is 5 and dx by dx is 1, right? Then this one is equal to 5. Also, you can get this differential immediately by the formula we have introduced, right?
Yes, sir.
Okay, also you can just find this one. The prime is equal to 5 immediately. Also, you can use this formula. And let's see another.
Cx prime, it's equal C.
Okay, here here is 2x square by dx. Right here, this one is C, and this one is F.
F.
Then we get this one, and this result is
2
2
dx squared by dx.
dx square by dx
dx equal to x.
equals to 2 times 2x equals to 4x here, right? Also, you can get this one immediately by the formulas last time, right? It's equal to 4x immediately. Also, you can make use of this formula of the product rule, right? When one of the function is a constant function here.
And the other is square.
Yeah. And after the introduction of the sum rule, the difference rule, the product rule, we also have the quotient rule here. The quotient rule, the differential of f by g by dx here, the quotient of f and g, right? This differential
Yes.
equals to, this is a little complicated here. The g times df by dx
minus
f
Minus
and
F
D
D G by dx.
dx here, and by
square
g square.
square.
Okay, and
Low
also
sheet.
you can remember this one as the prime type.
Yeah.
It's
This is much clearer. F prime g minus
GF prime.
g
F prime
No. It's minus F G prime.
It's the same one. Okay, I was right. Okay, F G prime, right? Right? Yeah. And this is the quotient rule here. G square. You do not know this G. G is here. G is here. Okay. The quotient, the differential of the quotient of f and g, and here is a g square. Also, we can make some exercise for the quotient rule here. We have the differential of sin x equals to the differential of sin x equals to what?
Minus cosine.
No
Minus
no manners here. Again, okay?
Sorry,
Cos x
class.
This is
Cosine.
This cosine.
Cosine X. Yeah.
yeah.
Both of them are
Yeah.
similar. That's why it's
And the differential of cosine x equals to
Minus
minus
sin x.
that's minus
Minus
x.
x.
Yeah,
Minus
yeah.
x.
Here. Then we want to calculate the differential of tangent x.
It's sine X by cosine X prime.
Yeah. So we can make use of the quotient rule here, right? Because
Yeah.
tangent
Yes.
x equals to sin x
Sin x.
by cosine
By
x
cosine x.
here.
Cosine x.
And we apply the quotient rule here.
Cos X time.
This
Sin X
one
prime.
is the F. This one is G, right?
Right, Lakshmi.
And
Yes.
we can
Actually, and we
add
need to
this one.
apply that on.
Sin x.
First is cosine x, and df is d sin x
Sin x.
by dx
Cos x.
minus f. F here is sin x times dg. G here is the cosine g,
Cosine
cosine x. Sorry, d
Sin X prime.
cosine x by dx. And here is g square
Cosine X squared.
Cosine
Cosine
Yeah.
x square.
cosine x square, right? Then calculate this one.
Sin X.
This one,
It's cosine X squared.
cosine x, right? Then
Yeah.
equal
Now
to
she's cosine x. Now she's
Cosine x square.
it's cosine x square or cosine square x.
yeah, sin x, and this part is negative. Is minus
Minus. Yeah.
Minus
Minus
sin
sin x.
here is cosine x square
By
and
x.
equal to
1 by
1
Yeah,
by 1
yeah.
divided cosine cos x, and it will be
here should
sec
be
square x.
here, right?
Yes, Lakshmi.
Sin square cosine square x. 1.
And the first part is 1. This one.
1
Then
divided by cos x equal to sec x.
yeah. It's equals to secant square. Secant square. Right?
Yes, Lakshmi.
Right, Lakshmi.
Then we find the final results here. The differential of tangent x equals to this one.
By cos x square x.
Yes, and you know that secant x is 1 by cosine x, right?
Yes. Right, Lakshmi. It's also.
Okay, then we can find the differential of tangent x by making use of the quotient rule here. Like this one, right? And after the introduction, I hope you can do some exercises here. I give you 4 exercises you should do.
now, Laushi.
No,
Homework, Lakshmi.
What?
Homework, for homework.
no, not homework. Here, just here.
Class
Now,
start.
we have
Now.
now here.
Not homework. Don't be nervous. Make use of the differential rows here. The first is y equals
minus x.
you can also write on your paper and send in our WeChat group. I think these 4 are easy. Oh, these 4.
Laushi, can you check?
Yes, I have C. Wei, you should simplify the final result here.
Yeah, it's -2 plus 3 by x cube. No.
Here, 3x plus 3x squared by x6 to the power of 6. You should simplify this one. And in the third one, you also, the third one is not correct here. check it, okay?
The third. Laushi, number 3. Laushi. مش ياسر.
Lauchi, we can't hear you. Well, Lauchi.
Oh, Laushi.
Because I'm not talking now.
Okay.
I'm waiting for your results.
Ah. Do it a minute.
Okay, if you do not have any WeChat account, you can practice, and I will explain the final answer. You can follow me, okay?
Okay, Laushi.
Laushi, could you check mine?
Laushi. You said number 3. It's false. No, it's 2. Laushi.
Laushi, could you check mine? The third one.
لا حول ولا قوة إلا بالله.
The third one, 220.
No, that's not me.
Which one is your?
Farah.
Oh, the last one, right?
Yes, Laushi.
You missed the first one?
No, Laushi, I just did first, second, and third. I'm doing the fourth one.
And okay.
Third one. Could you please check the third one?
It's correct here. Okay.
Is it okay? Is it okay, Laushi?
Yeah. Okay.
I was confused about that.
Yeah, let's go to explain these examples. I think these 4 are not difficult, right?
Yes, Laushi. I just did the
Okay. We will give
simplified
the
that.
solutions here. Solution here. The first one. We use the first one, the sum rule, right?
Yeah.
And we calculate the derivative part by part. And the first part is the derivative of this one, the derivative of 3. So it equals to 1 prime equals to the first part. The differential first part is
minus 2x.
Minus 2x. And the differential of constant 3 is 0, right? Then it's equal to minus 2x here. This is the first one. I see the first one. Yeah. The first one, or you get the right answer here. In the question 2, also we use the sum rule here, right? Calculate the differential of them part by part here.
Laushi, can I answer?
Yes, you can answer.
It's 2x plus 1.
2x plus 1, right? And here,
We
you
need to
should not
simplify
forget-
that again.
Yeah, the final answer is correct. And when you calculate this one, you should know the differential of a constant equals to 0, right?
Yes, Laushi.
Don't miss this point. The final answer is correct here. And the third one,
Lauchi, can I?
yeah.
It's 4x power 2 minus 1.
This
Then we need to differentiate that again, and that will be the f plus
one, right?
formula.
Yes.
Yes, Laushi.
And here, we also calculate the derivative part by part. First, we calculate this part,
Yes.
this part separately. And the first part is the
Yeah,
product
Laushi,
rule.
I get it now. I make a mistake. Yeah, you're right.
We should use the product rule, right?
Yeah.
Yes.
It's y equals to 4/3 times x 3 here and minus x. And the first part, we should use the product rule. And here, g is a constant, right?
Yes.
Yes.
Yeah.
So y prime equal to
4
4 by
by
3.
4/3
3x
x square
2.
minus 1, right?
Yes.
Oh, sorry. It's
Laushi,
this
can you hear
one.
me?
And you should simplify the final answer here.
To get
Right.
4x.
And 3 should be cancelled here. It equals to this result. It equals to
Yes.
4x
4x
square minus 1.
square minus 1 here.
Yes.
And
Four into
your
2.
answers, yeah, I think all of you master this point equals to 4x squared minus 1. Okay. And the first one, also, we should calculate the differential of them one by one, right? And
Yes,
this
that's
one
right.
is easy. This one is easy. And this one,
Little complicated.
yeah, you can use it as you can regard it as a quotient rule here, right?
Yeah.
This is f and this is g. But here, we want to calculate this one easily. We can regard this one as a times function here. It's equal to x minus
Minus
3, right?
Minus.
We can use this
Yes,
one
that's
to calculate. We can use this one to calculate a differential. Then
Laushi, can you explain third one again?
which one?
Third.
The third one?
Yes,
Which
yes.
step you don't understand?
The second part.
The second part here or here?
Yes, Laushi.
Here?
1 minute. I can't see. Yes.
This one you don't know why here to here?
Yes, Laushi.
Here. Do you remember the CXN, the prime of CXN equals to CN X N minus 1. And here, C is 4/3, right? And
Yes,
n
Lord.
here is 3.
Mhm.
Then it's 4 by 3 times 3. And n minus 1 is x2 here,
Mhm.
right?
Yes, yes, and after the three numbers goes and 4x plus a to minus 1. Okay, Lash, I understand. Thank you.
Okay. So this is the third one. And the first one, we regard the last one, 1 by x3 as 1 by x3 as x minus 3. And we calculate the differential of them 1 by 1. The first one
0.
is 0. And the second one
One is
2
minus 2.
Minus 2
minus 2
minus 2. And the last one,
plus 3x
plus
to the
3x
power
squared.
minus 4.
Plus 3.
we know
minus
this
3,
one,
minus 3x
x
power
negative
minus 4.
minus
Minus
3 dx equals to
Minus 3x to the power
minus
minus 4.
3 x minus 3 minus 1, right?
Yes.
Yes, Laoshi.
Then it's equals to minus 3
X to the
x
power minus 4.
minus 4 here. And here, you should not forget this label, right?
Plus 3.
Minus 3 x minus 4. Then
Plus.
we
Plus.
know that it's
Minus 2 plus.
negative. Here is plus
Plus.
x.
Yes.
Minus
Oh, sorry, 3
3,
x
3
minus 4.
3 by
or
Minus
3x
Right?
plus 3
And
by 4 to the x to the power 4.
yeah.
Or minus.
Often we write this one as
So Laoshi, I
3
just simplified that
x
3 by
4
x
here,
Simplified it.
plus 4.
right?
X squared.
Laoshi, I just simplified that again. That would not be accepted.
Which one?
The last one, I just simplified that again. I just
Differentiate again.
differentiate again.
You don't need to differentiate it.
Oh, sorry, Laoshi.
Okay.
Laoshi, how
You
we
could-
do this?
You
Laoshi,
differentiate minus 4 also.
Laoshi.
I don't-
You don't
Yeah,
know
this
how
one.
to calculate
Class like
this one, or
Yeah,
you treat
Fine,
this,
I'm on fine.
you don't know how to
yes,
calculate this one.
yeah.
Also, here, first, it's equals to x minus 3. This way, this step, you know it, right?
Yeah.
Right?
Yeah, Laoshi.
Yeah, you
Yeah.
know this one. Then here, we calculate the derivative of the last factor here. And it's equal to xn, the prime of xn equals to n x n minus
Minus
1.
1.
Here
Yeah.
n is minus 3.
Yeah.
Yeah, n x n minus 1.
Yeah. I
Yeah.
understand.
Then it equals to minus 3x minus 4 here.
Yeah.
Any questions?
No, Laoshi, we got it.
No, Laoshi.
I think these 4 are basic questions about differential. You should know how to calculate this kind of problems. Okay?
Third one is coming soon.
And this,
Lashi,
okay?
can you hear me?
Yeah. Just say it.
Okay, I think I have joined 20 minutes before due to I don't know when the class started because it's a shortfall here in no electricity, so no Wi-Fi, no data.
Okay,
why.
I have recorded the class and I will share the record in our WeChat group after class.
Yeah. I
Okay.
see every record after class and WeChat. No, and the Chuxing app, right?
Okay.
Okay.
Yeah,
Thank
yeah.
you.
Yeah. And this is for access, which is easier. And also, I will give you another practice.
Another.
Go on. You should practice more. Then you can master this point.
Yeah, Laoshi, of
Yeah.
course.
The fifth one, y equals to ex times sine x.
To the power x should be to the power x. Sin x.
You can write it on your paper.
Yeah, which
Yeah,
formula we used, Laoshi?
X squared plus 2x minus 2x plus 2. Just do it, okay?
Okay.
Laoshi, can you write the rule of c power x? I can't remember it.
You can this notes.
The note,
The rule of this Laoshi, this.
I will share it, okay? Oh, okay. This one.
Because I can't remember.
You can't remember this one.
Yeah.
Okay. Okay. Here. A is a constant here.
Laoshi, it's a power x or a time x.
Which one?
This Laoshi.
Power
A
x.
power x prime. It's a power x or a time x.
Which one? Here? Where? I can't see. Here? Or this one? Or this one?
Yeah.
Times. Here is the times. Yeah, it's times here.
Time x.
No. A to the power of x times log. Yeah. As this one. Oh. Oh, sorry, it's the end time. Do you have class after our class?
Yes, we have other class.
No,
When
Laoshi.
after class, Laoshi.
Yes.
No,
So
Laoshi.
you want to me to explain after the class, or you need Miss Jo to explain these practices in next week?
Okay, Laoshi.
What do you love, Laoshi?
Laoshi, we have a class after this.
Okay,
this-
okay, just stop now. Okay.